For page 2, we know the velocity function of a moving object, and we want to know how far does it travel. So the first thing to notice here is that the velocity function is non-negative. T squared over 3 plus 2t is bigger than or equal to 0. So that makes the problem easier for us. We just need to integrate it. So the total distance, I'll call it d, is simply the integral from time interval 0 to 3 of the velocity function, 1/3 t squared plus 2t dt. So you can see the problem's worth 8 points. You got 4 points for finding the right integral. And then, of course, I did ask you to find the distance. How far does it travel? So you did need to evaluate it. For this problem, this version of the exam, the velocity is just a polynomial, and it's super easy to evaluate. There were differences. I think one other group had velocity function 1 over t squared plus 1, which is still non-negative, but the antiderivative now would be the inverse tangent. So slight versions there. And again, 4 points if you could show me the right integral, and then 4 more points if you could evaluate it correctly. On problem number 4, we derived integrals as being a way to calculate arbitrary areas when geometry fails. And so here's the question about it. Find the area. So 1 over x squared, the graph looks sort of like this, and we're going to go from 1 to 3. So no tricks here, we're just going to integrate. The area is the integral from 1 to 3 of the function. And I'll set it up for the antiderivative. Let's write it as x to the minus 2. And then we evaluate it. And again, you all had slightly different functions here. I think one of them was 1 over x, in which case the natural log gets involved. And the other one, if I remember right, was just 1 over x cubed, which is very similar to this one. All right. Problem number 5. So people did really well with this. This was supposed to be a little bit more involved in antiderivatives. For part A, no tricks really. Most of you knew exactly what to do. Again, the way to solve this is to look at the bottom and say the derivative of the bottom, there it is, sitting right there. So to write out the details, we're going to substitute for the bottom, and then we get e to the x dx is my du, and then notice it just becomes 1 over u du, which is the natural log. I'll let you finish it. Number 5, part B, was maybe the trickiest problem on the class. On the test, there was a homework problem very similar to this. If you hadn't seen it on the homework, I probably would have given you a little bit of a hint because we're going to do substitution, but we have to do a little bit more with it. And there's a lesson to be learned here, which maybe we'll carry over into Calc 2, and that is sometimes we can get more out of a substitution than just the chain rule that we use to come up with the process. So I'm going to let u be the inside part of a composition, and then I get the integral, I get the square root of u, and then the dx is just du. So when I go to convert it to u, unlike every other problem we've done by substitution, with the exception of that one homework problem, notice this x just doesn't go away. Like the e to the x over here went away on my differential. This one doesn't. So what are we going to do about that? Usually we can account for it on the differential, but it doesn't work here. Well, let's remind ourselves. There's a relationship between u and x. It's given by that thing right now, right there. And I can solve for x. So the x that I can't replace with the differential or the immediate use of the substitution, I can solve for it, and I get u minus 4. So let's see if we can squeeze that in here. Now that's bad. U minus 4. Okay, that's kind of ugly. Let's stretch it out. And then if I multiply it out, now that the square root has been simplified, it multiplies out nice and easy. Let me do it and set it up for the antiderivative. So I get the square root of u times u, that's u to the 3/2, and then I get minus 4, the square root, which is u to the 1/2. And now those are just power functions, and the antiderivative is straightforward. A few constants to juggle, but works out nicely from here. All right, which takes us to page 3.